moving to music. So when babies are bounced in sync to music, they actually develop more a sense of attachment and trust to the person that's bouncing them than if they are bounced out of sync to the music. So my name is Indre Viskontas, and I have backgrounds both in neuroscience and music. I'm a classically trained operatic soprano. And for a very long time, I kept these two interests really separate, in part because my intellectual outlet was neuroscience and my emotional outlet was music, and I didn't want to tarnish either one of them. That was my view. And even when I read sort of science of music stuff, it kind of didn't feel true to what it was that I loved about music. Oh, do I need to talk into the mic? Okay. Until I did a master's in music, and I realized that a lot of the ways that musicians are trained does not align with what we know about how the brain learns and remembers and how plastic it is. And so I thought that maybe one way in which I could bridge these two interests was by bringing some neuroscience to the training of musicians to try to help them develop more effective practice strategies. And that led me on a journey more and more to sort of realize that I was actually approaching the question completely incorrectly. It wasn't so much like what science could tell me about music, but rather what music can tell me about the brain. This obsession we have with something that doesn't even exist in the reality outside of our brains is so bizarre and so informative about what it means to be human and our own psychology that I felt that that's really what I wanted to devote more of my time to. So I thought about different ways of doing this. I developed a couple of courses at the San Francisco Conservatory of Music. I did some writing and some reading, and then I thought, well, maybe I should try to spend some time putting this together into a book. And I pitched it to a couple of science writers, and they all said, you know what, that's not a book I want to read. That's something I want to listen to. So why don't you think about making it into a podcast? Well, up until then, I had been podcasting. I'm the host of a podcast called Inquiring Minds, and so we are a long-form audio format, puts out an episode every single week. We talk to scientists and thought leaders, and we bring science to the general public. That's the goal of Inquiring Minds. And I thought, yeah, maybe that's true, but except if I did a podcast about music and the brain, I really wanted it to be much more narrated, curated, specific to the kinds of sounds that I would want to include as opposed to a long-form interview format. So I did that, and the podcast is called Cadence. We have 2 seasons out. And after the first season, which was kind of an overview of music and the brain, things that I thought were interesting, some informed by stories told by musicians, I started to think about ways in which music really can tell us about ourselves and how we can heal using music, right? It's this bizarre thing about how music can be used in therapy. Why is it that people with Alzheimer's disease still retain the ability to enjoy music? I watched the great documentary Alive Inside and was really moved by it. So the second season was really about music as medicine. And here's where the irony comes in. After putting out the second season, an editor from Chronicle, book publisher in San Francisco, approached me and said that she wanted to turn it into a book. So I think that's kind of funny. So here's the book. It's called How Music Can Make You Better. And as my mother says, better at what? She's very offended by the open-endedness of the title. But Chronicle is, they put out cool books, a lot of cookbooks, all the, goodnight construction site stuff that my son loves. And the whole idea of this was so that we don't tell you what you're better at, right? That there's an open-endedness to it. That's part of the appeal of the book. And I like that because it goes along with how we approach music. As I mentioned at the very top, music is not in the sound waves because I can listen to music that I love and have a very different experience from what you would experience if you don't like that kind of music. So, my father-in-law likes to say that he likes all kinds of music except opera, which of course is a dig to his opera singing daughter-in-law. And my answer to that is, well, but what kind of opera? Because there are so many different genres in opera. There are operas that I don't like either, and there are operas that I love, and so forth. And the whole reason that we can have very different physiological responses to music speaks to the fact that music is about experience. It's about how your brain has been shaped by your own experiences, and that dictates what physical reactions you might have to it. Now, it doesn't have to be conscious. You don't have to sort of consciously choose to enjoy a piece of music. In fact, sometimes you discover music that you've never heard before and it moves you profoundly. But there is something about the way that your brain interprets that sound, finds the layers of meaning into it, that is different for you versus for someone for whom that is not at all affecting. Music is interesting too because some people really do hate certain kinds of music. They don't just not like it, they hate it. There's an emotionality to the way in which they don't like it. And often we see these silos within different niches of music, just probably like we do in different niches of podcasts, right? So, people who like classical music sometimes really hate rap. People who like rap sometimes really hate pop music, and so forth. So, to me, that was another interesting way of looking at, it's just a sound wave. There's nothing inherently, emotional in the actual physical stimulus. Why does it incite such visceral reactions? So, the first part of the book is about what is music? How does our brain process it? How do we turn this physical sound wave into something that can incite wars or make us fall in love? And the second section is really built up out of the podcast, which is music that can heal us for better or for worse, heal our bodies. So we'll talk a little bit about that. And then finally, the last section is about music and society. And can it make society better? Can it make society worse? That's why it's an open-ended question. So I start off a lot of my talks by having you think about what is music and what it's for. So I approach the study of the brain from an evolutionary perspective because there are remnants of our nervous systems in all the other animals that have nervous systems, and we can learn a lot from what it is that they do and how they behave about ourselves. And of course, there's this very famous line by linguist Steven Pinker, Boston, I don't know if he's a native, but he lives here now, right? And he said, well, look, music isn't, our brains didn't evolve to enjoy music, it's really auditory cheesecake, right? So it's this idea that we didn't evolve to love cheesecake, but it hits all the sweet spots that that our organism evolved to find pleasure in. And so that's that view, and I'm not saying that view is particularly wrong, but that view also ignores the fact that there is this long sort of culture of music within human civilization, but also that even from the first ways in which we start to communicate with each other, even in the womb, we listen to the differences in the melodic intonations of speech, not in the semantic parts of speech. When you talk to a baby, you talk to them with prosody, and it doesn't really matter what you say, it matters how you say it. And I would argue that part of that is music, and you're laying down the foundations for that individual's brain to start processing sound differently. So if you're still not convinced that music isn't in the ether, that it's not in the sound waves, I want to do a little demonstration. I apologize, I haven't tested the audio here, so hopefully it'll work right away. Where I hope that it'll change your mind. And if you haven't heard this before, hopefully it will blow your mind. And if you have heard it before, then I invite you to think about already the fact, when was the last time you heard this particular bit of audio, and what does that mean in terms of how you interpret it now?
The sounds as they appear to you are not only different from those that are really present, but they sometimes behave so strangely as to seem quite impossible. But they sometimes behave so strangely, 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 so strangely, so strangely, so strangely, so strangely.
So what happened in the course of you listening to that little bit of audio? Some of you started actually trying to figure out what is the notation as it turned into music for you. Some of you started to feel the beat. Some of you got a little bored and thought about lunch. That's really good. That actually makes the illusion stronger. For those of you for whom you still don't know what I'm talking about, it's probably because you were paying too much attention to the audio. And I imagine at a podcasting conference, the proportion of participants for whom this doesn't work is higher than average because you were probably paying too much attention. But let's listen to that entire first phrase again and think about how you interpreted it the first time you heard it and how you interpreted it now.
The sounds as they appear to you are not only different from those that are really present, but they sometimes behave so strangely as to seem quite impossible.
For me, it sounds like she breaks into song halfway through the phrase, right? And what is the difference? The only difference is that I have experience listening to the repeated phrase over and over and over again. It's just repetition, but yet my brain now interprets it as music. That is so strange, right? So that is the mellifluous voice of Diana Deutsch, who's a pioneer in music cognition research at UCSD. She actually just put out a really great book. And what it tells us is that when we listen to audio repeatedly, our brains look for other patterns that go beyond just the words that we're hearing. We go beyond just interpreting the sound as the language and trying to see it as that form of communication to finding other layers of meaning. The emotionality, the beat, the melody, whatever it is, our brains start to analyze it in a different way. And it turns out that the one universal thing about all music that we know of is repetition, except in 21st century composed music that explicitly avoids repetition, and for a lot of people, it's not music. For a lot of people, it's really hard to listen to because they don't know what it is that they should be hearing. They don't know how to interpret it. I can say this because I perform a lot of 21st century composed music, and I've had the experience of putting in a ton of hours into preparing a piece that I think is really brilliant, that I think was really deeply layered with emotion and truth and story, and then I perform it in a bar full of 3 people, and then they're usually my mom. So, I understand that it's not widely accepted as music because people don't know how to listen to it. And yet, if you then spend more time with it and you, in fact, insert repetitions into 21st century composed music, more people will find it enjoyable. And that's exactly what my colleague Lisa Helmuth Margulis did. She wrote a book about it too. But she took the compositions of Elliott Carter and Luciano Berio, 2 highly respected 21st century composers, or 20th century composers, and she hacked them to include repetitions where there weren't any in the original compositions. And she found that people who listened to the hacked versions found them more enjoyable, more interesting, and interestingly, more human, more likely to have been composed by a human than by a computer. So that suggests to us that there is something about this repetition, our ability to listen to music differently or sound differently through repetition that happens when our brains are able to figure out where the patterns are. So that's my next point, is that, what does this mean? This highlights, in fact, one fundamental property of the brain, which is that the brain is interested in predicting the future. It wants to know what's going to happen so that it can coordinate its behavior appropriately. And so we find patterns in places where maybe their patterns aren't meaningful, but we enjoy it too. Not only do we look for patterns, we also actually find it enjoyable. So patterns that are meaningful to us, like faces, we see everywhere. In fact, it's one of the reasons I think that kids are really find electric sockets appealing, because they're like little tiny faces in the wall the kids want to put their fingers in. That's why we have to baby-proof them. It is a compelling stimulus for us because faces are really important to us and they're really meaningful. So now that I've completely changed your brains forever, I guarantee the next time you hear the Diana Deutsch illusion, you will hear it on the first hearing as if she breaks into song midway. Think about that for a minute. For the rest of your life, or for at least as long as Diana Deutsch has been using this illusion, it persists. Like, what other neurological thing can be so quick to change how you will interpret this in the future? To me, that is really remarkable. And the fact that means that, in fact, how you interpret sound, whether you find it meaningful, whether you enjoy the music you're listening to, depends entirely on how your brain approaches processing that information. Okay, so most people, when they read the cover of my book, and especially my mother, they think about the Mozart effect, right? How studying classical music can make us smarter. So I want to address that right off the bat, and say that there is this huge industry. We're told to play music, especially Mozart, to the baby, even when it's in the womb, because this is what's going to make it smarter. And the question is this true? Well, looking at the original study in which the Mozart effect was coined and sort of quote-unquote discovered. This was a study of undergraduate students, 35 or 36 at UC Irvine, who were given one of three conditions. They were going to be asked to do a bunch of IQ tests, a few minutes, and they could spend the 15 minutes before the IQ tests either listening to Mozart's piano sonata, sitting in silence, or listening to relaxation tapes. And it turns out that listening to Mozart's piano sonata did improve their performance on the subsequent cognitive tasks for about 15 minutes. Okay, so that's the Mozart effect. The question is, if you gave them a shot of espresso, I bet it would last longer and be more robust. So follow-up studies showed that a chapter from a Stephen King novel was just as effective. Pop songs by Blur, just as effective. What's not effective is sitting in silence and getting tired and bored before you're about to do a bunch of IQ tests. So now I tell my students, you can listen to music before my tests, but you can also, have a shot of coffee, and that will have the same effect. So the listening to Mozart for 15 minutes does not make you smarter. It makes you more awake. It's an arousal effect. So what about actual music lessons? So forget passive listening. What about active participatory music making, which I think is what most people think of when they think of the Mozart effect. If I learn to play Mozart, then my brain is going to be shaped differently, and I will, in fact, be smarter. And there's some evidence that this is true. So one of the original studies was by Glenn Schellenberg and colleagues, where they looked at kids who were getting keyboard or voice lessons individually, and they compared them on a bunch of IQ tests with kids who got drama lessons or no lessons, and they found a small effect. Now, the drama kids actually scored higher on tests of empathy, which I think is kind of interesting. That's exactly what we're doing when we're teaching them drama. But the keyboard and voice kids scored higher on the IQ tests. What does this mean? Well, it's hard to interpret, because one of the big distinguishing factors between kids that can go to private music lessons and kids who can't is socioeconomic status, parent education. And that's a huge driver of performance on IQ tests. So that's one thing that's really plagued this work, is that we can't really separate easily performance, or enhancement from music lessons from SES. But what if we could? So in a follow-up study, actually done here in Boston, they took kids from Boston public schools, and they randomly assigned them to two groups. One group had group music lessons, the other group had private instrumental lessons, and it was over the course of just over a year. And then they looked at their brain scans before and after the interventions to see how different parts of their brains were changing anatomically, and on how they performed on different types of IQ tests. And they did find that brain volume in areas that are closely related to the skills that these kids were developing did in fact show greater changes. So primary auditory cortex, our ability to hear. Primary motor cortex, so not only sort of how we're manipulating fine motor movements. And then the corpus callosum, so the white matter tract that crosses both hemispheres and helps you do things like bimanual coordination. So it shouldn't be surprising to us that the kids who were literally using their brain to develop skills in these three areas actually showed greater brain volume. Although the fact that they did that within just a couple of, just over a year is pretty remarkable. In this study, they did not see far transfer, which is this notion that you can also make yourself smarter in skills that are not closely related to music. But in other studies where those kids were taking instrumental lessons for at least 3 years, they did seem to outperform their counterparts on a number of tests, both closely related to music, like auditory discrimination, and distantly related to music, like math and verbal reasoning. And it turns out that there was a dose-response effect here, dose-response curve. So the more training you had, the bigger these effects were. But to me, that still, is suggestive, and it's interesting, and I think it's important. But the kicker, the reason I think that we need to have music programs in every single school, particularly in areas where there are kids who are disadvantaged or at risk, is because music boosts attendance in schools. And what I'm going to talk about in the last part is the fact that music is a social activity. It helps us bond with each other. So if you have a music program, that makes it more likely that the kids are going to come to school. And that is the bigger driver of outcomes. So for example, if you can keep one kid out of prison because he or she went to school instead of hanging out on the corner and getting involved in things that might eventually make them end up in prison, you'll pay for 10 years of a teacher's salary. So this financially makes sense. And that's, I think, one of the biggest reasons why, forget the Mozart effect, we want music as part of education. And it needs to be music that appeals to all students, not just classical music training. Okay, so that gets me to music as medicine. And here, when you listen to music, it just automatically makes you feel better. It boosts your mood, unless you're listening to it for another reason. Like, for example, it's a ritual in which you're grieving, right? So it can also help you show some of those emotions. And when we hear about music as a mood booster, we often think about the neurotransmitter dopamine, which you might have heard being called the pleasure chemical. Dopamine is not just a pleasure chemical, it's really a salience chemical. Dopamine is high in the brain when you're doing something that is going to lead to some kind of likely emotional reaction. So even negative experiences can lead to big boosts in dopamine. But as scientists, we don't want to rely on you telling us that you're having a good time. We want to be able to measure it. So often these studies use a physiological measure called the chills, right? When you get goosebumps on your skin from listening to music. And we can see that in a number of different measures, in respiration rate, and your temperature, in terms of all these physiological measures. So we don't need you to tell us that you're having a good time. We can see it with some of these other measures. And when we look at what's happening in the brain when you're getting the chills, we do find that dopamine levels are higher in parts of your brain that are involved in reward, in the reward pathways, which are also important for motivation. So why do we do the things that we do? Because we find them eventually rewarding. So anything that is going to lead to reward drives our behavior, right? So this is why people who get addicted to drugs that target the reward system find it really hard to do anything but seek out that drug. Okay, that's the whole point of the reward system, is to shape our behavior to do the things that will be ultimately rewarding. Okay, but it's Saturday morning, so I'm going to get into a little neuroscience, but I'm going to try to keep it super simple. Just kidding. Okay, that's a neuroscience joke. Okay, so here's the caudate nucleus, which is part of the reward system. I like to think of the caudate as the little scientist in your brain. It's the part of your brain that tracks things in the environment that are going to eventually lead to positive or negative outcomes. So if you're addicted to drugs and you take those drugs in the same place every single time, the caudate is keeping track of that. And when you get into that environment, it will actually help your brain do the opposite of what the drug does. So then you will feel like a higher craving for the drug, and you also develop tolerance, which means you need to take more of the drug to get the same effect. This is why people who overdose often do so in novel environments, which is why we hear about rock stars who died in hotel rooms. Because the brain, the caudate, is not prepared for this onslaught of the same dosage of the drug that might have been safe in a home environment, but now is no longer safe. Okay, so the caudate is about creating desire. It's the wanting part of the reward pathway. And then there's the party in the brain. This is the nucleus accumbens. This is the liking part of the brain. And if we look at what's happening in terms of dopamine levels in these two regions of our brains while we're listening to music that is about to give us the chills, something really interesting happens. So here is a graph showing the different levels of dopamine in these two regions. You'll notice in the top line, that is dopamine levels in the caudate. So this is what's happening before you get the chills. And the chills usually come at the climax of a piece. We can talk about the features of a piece that give you the chills. But what you'll notice is that in the anticipatory phase, caudate dopamine levels are high. And my singing teacher used to always say to me, Indre, it's not the high note that's important. It's all the notes leading up to the high note that are important. And I would say, bullshit. If I miss the high note, I don't get the job. But she was right. and this is why. If I don't set up the high note properly and it's unexpected, it is not at all interesting. It's just kind of a freak sound. But if I'm setting it up and your brains are able to predict what's happening next and you're expecting this reward, boom, you get a big dopamine rush in the nucleus accumbens and it's a party for everyone. Okay, so that gets me to one of the sort of final things that I wanted to talk about, which is that, so I guess I should bring this back and say, in terms of how this is used to heal us, I think one of the most remarkable uses of this information is actually in patients in Parkinson's disease. Because in patients with Parkinson's disease, what you get is death of cells in the substantia nigra, which is a brain region that produces dopamine. So their levels of dopamine in their brain are already lower. And one of the things that people think of people with Parkinson's disease as having tremors, and that's the primary symptom. In fact, it's not. The primary symptom is an inability to initiate movement, an inability to get going. And so you need the motivation to get going. And it turns out that listening to music provides you both with a dopamine boost and the motivation to get going. And there's a third thing that happens. Those cells project straight into a part of the brain called the basal ganglia, which is about putting together motor movements and allowing you to do things like walk. Well, if you boost these levels, what we actually also see is that music entrains the basal ganglia by giving it a beat, right? In fact, we don't see the rhythm, we feel the beat. Beat is all about movement. And so in these patients with Parkinson's disease, you can use an intervention where they wear like an accelerometer that is tied to a music listening device. And if they are moving at the right speed, the music keeps going. So they have their motivation up, they have their dopamine levels up, they have an entrainment to a beat. So all of this is like helping. And then if they start to slow down, the music stops. So that motivates them to keep going. And it can be remarkable how effective this is, without any kind of direct intervention. Okay, so I want to end with the last section of my book, which is about music as social glue. And I want to just say that this is where things get a little problematic when we think of music as being universally good. Because one of the things that music does, as I mentioned, is that it helps us form bonds between other people. The reason that it does that is in part related to moving to music. So when babies are bounced in sync to music, they actually develop more a sense of attachment and trust to the person that's bouncing them than if they are bounced out of sync to the music. And the same thing happens if we take adults and we put them in a room and we do something where we're out of sync. Those adults don't feel the same kind of bonding as what happens if they are in sync with the experimenter. In fact, even in studies where they show where the experimenter then goes and accidentally drops a bunch of pencils, those individuals who were dancing in synchrony actually are more likely to pick up the pencils. What we see now then is the fact that, and one of the things that increases your ability to synchronize is if you snort oxytocin. So you can there's like the spray that you can put of this hormone, oxytocin, which we know is involved in attachment. And we know it's also boosted when we're listening to music, particularly when we're listening to music and we feel as if we are in sync with other people in the room who are also listening to music. And oxytocin levels help us feel like we are more attached to the people with whom we are now associating, but they also make us more aggressive towards people that we consider threatening to those we love. So this is where East Coast, West Coast hip-hop rivalries are really based in physiology. There is a truthfulness to the fact that the higher your oxytocin levels are, in the experiences in which you are bonding with your group, the more aggressive you will be towards people who you think are threatening. And that's sort of the nefarious side of music. So I want to end with just a little video that kind of pulls a lot of these ideas together. It shows us how music can help us connect with each other, help keep us motivated to do something that is really hard. So I have a 5-year-old son, and the hardest thing in the world for him is to say he's sorry. It's so hard. Avoids eye contact, does anything he can not to say he's sorry. And I know that it's really hard for him, but it's something that he needs to learn because it makes everything better, right? So what if you could use music to develop the motivation, the attachment, the trust, the fun in teaching kids for whom this is a really difficult thing, this one critical aspect of social bonding. So I want to play you a video that was uploaded by a music therapist who I really admire, and her work with a child with developmental needs and how she says she's sorry. So just to give you a little bit of context, this child said some bad words in music class. And so she's being told not to do that again.
Why? Because we have bad words in music today. Here we go.
All right, thanks very much.
Some studies or experience people didn't like any music?
Yes. Okay, so there are people who have what's called congenital amusia, which is an inability to enjoy music. Now, not all of these people hate music, so that's sort of what we think of as actual tone deafness. So, for example, they can't, if they're singing Happy Birthday, they can't actually get the melody right. It runs in families, so there has to be a genetic component. It's very rare. And even for some of those people, they still want to like music. There are actually cases of people with congenital amusia who are really trying to overcome this because they still seem to find some enjoyment. But there are others in that cohort that don't understand music. There are also people who are hard of hearing or who have cochlear implants that I've worked with who don't understand why anybody would like music. So I remember one patient that I spoke to was in his 50s or 60s, and he had been hard of hearing essentially from very young age, and he had a cochlear implant, and he could hear speech perfectly well. So we could interact with that, but he never understood why anybody would pay a single penny for music. And he would say things like, well, I'll go to the park if it's free and I'll sit there and listen. It's fun to have a picnic. But I don't understand why anybody would pay money to go see the same orchestra in a hall. The value proposition to them was completely foreign. And when we look at what's happening in patients like that, what we see is they spend a lot of time trying to understand parse speech, which is more useful for them in their daily lives, but that music is so complex that it's a lot harder for them to learn to sort of love and appreciate music again.
Your scene there reminded me of the scene in the King's Speech,
Mm-hmm.
when he said he was trying to help the king stutter.
Mm-hmm.
Maybe it'll help if you sing it.
That's right.
When you see things
Yep.
like that, how does that, are you like, wow, okay, this is kind of bringing this theory, if you will, to the masses? What do you think when you see stuff like that?
Yeah, so it tells us that the way music is represented in the brain is on multiple different levels. So, but speech is pretty localized. So in the left hemisphere, in the frontal and temporal lobes, there are these two sections of the brain that are critical for speech comprehension and speech production. If you have a stroke or a bullet wound or you damage that part of the brain, you will see people who have impairments in speaking, but they can often still sing. So in fact, I have a video of Gabby Giffords where she was shot in the head in the left, and she was rhetoric was her specialty before the injury, and then she couldn't speak after the injury, but she could still sing certain words, and that is because what we now know, so in the left side, I wish I had a whiteboard and marker. Okay, so in the left side of the brain, these two regions, the comprehension region and the production region, are connected by a tract of white matter, axons of neurons, such that it's bigger, it's nice and thick. So imagine you're working out a bunch of muscles and you're doing the same thing, you're developing a nice big set of muscles. So in most people, that language part is really well developed. On the right side, for anyone who's not a singer, that same tract exists, but it's much smaller, and it's just not as effective. What we find is that during therapy, especially music therapy called melodic intonation therapy, where you use, so like in Gabby Giffords' case, she had a hard time saying the word light or love. And so the way melodic intonation therapy works is that she could still sing it. So she could sing, "This little light of mine, I'm gonna let it shine." So the same, things, she could do it, but she, right? Okay, so what you do is you use melodic intonation therapy to get them to sing phrases that are important. So, and you tap too. So you go, "I love you," and you teach the patient over and over again to be able to, "I need the bathroom," and they learn to sing that, and then they can say those words. And what we see is a concurrent increase in white matter in that tract on the right side of the brain that is intact. So we think of music as actually a great model of neuroplasticity and rewiring because it both is multiply represented. So there are bits of music that are retained in many different diseases, neurodegenerative diseases and injuries, but also it's highly motivating. Right? So so the brain is shaped when it's motivated, right? So anyway, yeah.
So I have a question about how your brain works when you're listening to music and let's say studying. I have this constant fight with my children because I'm the kind of person that needs silence.
Yes.
When I'm writing a paper, I can't also hear somebody singing words.
Right.
So I'm always fighting with them. You have to turn the music off. You can't hear anything. But actually.
Yeah, for a lot of students, so multitasking really doesn't work generally in the brain, but if the students, it depends on the type of homework or studying that they're doing, but for some students we actually see music can have an enhancing effect because of the original Mozart effect study. It's more arousing to them, it's less boring. And what we have now is a situation in which kids just aren't bored almost ever, right? There's so many distractions out there. So they're very uncomfortable with boredom. And so their ability to focus when they're slightly bored, as is usually the case in a lot of the studying that they have to do, is really hard for them. So they're fighting this need for, some kind of stimulation. And so that's almost like multitasking in its own way. You put music on for them, and that just kind of gives them the arousal. It makes it more fun, and then they're able to do their homework. So, I mean, that's kind of we can talk about it a lot, because I think there are actually a lot of nuances, but I do think there are strategic ways that you can use music to help kids study, but that there's also the other side of it, which is then, do they become dependent on the music to give them the reward that they then need? So when they go and take the test, and now I find a lot of my students have a hard time focusing on the test because there is no music. And so now they have to sit through an hour-and-a-half long test, and by the time 30 minutes go by, they're bored and they have a hard time finishing. So, I think I think it can be helpful in the moment, but I also think that students have to learn to deal with their boredom, and maybe in a kind of not all the way. Like, you can't expect someone to sit down and do anything for an hour without ramping up to it, right? So maybe they use the music when they have to do things like problem sets or things like that, where they just need to get through it. But then they do a 10-minute test at the end of the study session where there's no music. So that begins to build their tolerance for focusing in the absence of that kind of pleasurable or arousing stimulus. And again, for different people, I mean, there's some, if we're podcasters and we're interested in audio, for us, listening to podcasts is probably less relaxing because we're starting to think, oh, that was an interesting thing, that cut didn't work. Oh, please, they really should have edited that out. That's a different type of listening than just putting it on, while you're cooking and just enjoying that, thing. For me, certain types of music, like I can't listen to opera when I'm studying because I'm sitting there processing it too much. But that's because, that's something that I do for a living. But, if I'm listening to Sarah McLachlan or, pop music, it's fine. Or instrumental music. I can listen to Beethoven's late quartets and do just fine. I have friends who are violinists who absolutely could not do that. So again, I think it depends on how much of your cognitive resources are being devoted to processing that music versus what it is that you're doing. But I wouldn't say, I used to be of the mind, no music while you're studying. And then actually some of the research shows that it can be helpful in certain situations, especially if the kids then create a positive association with what it is that they're studying, right? Now all of a sudden it's not like, oh, I have to do my homework. It's like, oh, okay, I gotta do my homework. And now I get this moment. So that's important too, right?
By your observation that babies and even adults react better when they can tell something is in rhythm. Mm-hmm. So how then does this explain the idea that certain people have rhythm and don't have rhythm?
So that's a good question. So just like we have genetic differences in height and hearing and everything else, there will be genetic differences in the way that you process beat, or they might even be, we don't know to what extent they are genetic versus how those early years of childhood, which are so important, what relationship you developed with sound. So for example, kids that are raised in a urban environment where there's a lot of ambient noise, they learn to tune out that noise, and later on they can show problems distinguishing speech sounds in noisy environments because their brain just shuts down all auditory information, right? So imagine you have a kid who also has a relationship like that with beat, right? Where they early on are taught that syncing with a beat is something that they like to do and that's pleasurable. Are they born with that desire to move to the beat, or is it that, whatever early environment, I don't know, right? That's an open question. But it is true that some people have a way of conceptualizing beat that is better than others. And, talking to percussionists, talking to people who are very, very good at this, a lot of them do develop a very different way of processing sort of the cognitive aspects of beat. So for example, I have this one percussionist that I talked to, his name is Jack Van Giem. He was a longtime percussionist with the San Francisco Symphony. And he has what he calls the bass drummer at the back of his head. So he has this constant beat and he does all these visual things, like he puts music into boxes and then he subdivides all the boxes, and it's this 3D visual image that he has in his head. But he basically says even when I know that I'm off, the bass drummer is always right. So he's just developed this very sophisticated way of processing beat information. But for most of us, it is really very much tied to our motor processing. So just as some of us are more coordinated, some of us then are going to be able to translate that into coordinating our bodies to the beat. And so I think that all those factors come in. And I think that for any given individual, there isn't going to be the same answer. I think that every individual is going to have a different series of strengths and weaknesses in that way. But I do think it's trainable. Just like developing motor coordination, you can become more coordinated. Maybe you won't become a gymnast or a hip-hop dancer, but you can certainly improve in your coordination through training. And I think the same thing is true when we look at beats. The other thing that's interesting about beats is that we see beats as being as synchronizing a lot of different physiological functions. So people who sing together in a choir, for example, synchronize their respiration rates, their breathing rates. We see the same synchronization in oscillations in their brainwave activity. And same thing too so we know that, and the more trained you are as a musician, the more easily you synchronize your brain waves to the beat of the piece that you're listening to. The other thing that we're learning is that it seems like, the faster a beat, the harder it is to sync. Actually, it's not true. The faster the beat, the easier it is to sync. Musicians who are really good can maintain a consistent, slow beat. I'm not very good. But musicians who are good can do that really well. And what we see are their brain oscillation patterns that follow that much more accurately than a person who's not trained as a musician. So anyway, That's the long answer is that you can train it, or the short answer I should say, that you can train it up, but there's also going to be differences in the way that you had your early childhood experiences and in the way that your brain processes that kind of information.
To go back to your point in the presentation, there is some amount of rhythmic understanding of beat that is innate in you.
I mean, yes. I mean, yes. From 6-month-old babies, that's right. They see this as an important signal, just like they find faces interesting. Faces are innately interesting. So I think that really speaks to the primacy of music, if we think of beat as a part of music, to the human endeavor, right? Is that we see that as a form of communication. You can boil it down to, well, if we're in sync and our bodies are in sync, that means that we are on the same team, right? We are, and it's tied to my ability to empathize with you, to put myself in your shoes, to theory of mind, a mirroring, like all that kind of stuff, can be at play. Yeah.
So in terms of podcasting, kind of conventional wisdom is great intro, great exit music, and some music in between can be helpful. If you were a consultant, is there a certain length of time and or how much music is enhancing versus distracting?
It's going to be highly dependent on your listener too. I mean, I have listeners who listen to Cadence who hate the fact that we sometimes have music in the background, and I'm like, this is a podcast about music, there's going to be music in the background, right? So I think there's a generational effect. I think for some people who are not used to listening to music all the time, and again, they focus in on the music, it can be very distracting if there's music behind speech. Whereas people who are, have grown up in an era where music is everywhere, it's just not so distracting. They kind of more tune it out. So I think it depends on your audience. I also think that, so if we think about, there's a kind of inverse U-shaped curve in terms of the kind of music we like, right? So if it's too simple, it's boring. If it's too complex, we don't understand it. So when it comes to what kind of music you're choosing and how much to have, I think it depends on how simple or complex it is, where the patterns are, and when they repeat. So when you're crafting, I mean, if you had the time to do this, if you were crafting a narrative and you were overlaying music, I would take a look at where the patterns are in the music so that you can, make sure that you're not overly repeating it. And we sort of see this already intuitively, like any good audio engineer can tell when there's been too much of repetition of a particular musical track, right? Like you're listening to music and it starts to repeat, like you notice that. So I think that's, the reason you notice it is because your brain is like, well, but now it's just meaningless. Now it's just this thing I need to ignore. But if it can continue to add meaning, so in most cases music is used to add emotional information, then as long as it stays meaningful, I think that's effective. So just like music is so subjective and we're not all going to agree on what is great music, I don't think there is a single set of rules for any particular podcast. But I do think that you can be very mindful and strategic about how you use it, knowing that our brain's going to look for these patterns, they're going to find meaning in them. So you want to make sure that the patterns in the music that you are overlaying match the meaning that you're trying to portray in the rest of the podcast. And then I think it is important to let people breathe, right? So you need to have some times when there isn't music. Yeah.
Question about music and mental health. I know for myself as someone who's highly anxious, highly depressive, and looking back on it, I realized music has been kind of a soundtrack to processing my own thoughts. Mm-hmm. And when I really got first initially obsessed with podcasts a couple of years ago, I totally cut out music and just swap that all with podcast listening. But over the last 2 years or so, I've had to intentionally make time for music because I realized there's just certain things in the background that aren't happening. Are there any specific research views on sort of the ability of music to help people process their own thinking, kind of what you showed in the video?
Yeah, so there is a lot, especially with anxiety. So we do know that music, so anxiety in part is a physiological response, right? So yes, it has a cognitive component, so you can create that physiological response with anxious thoughts, ruminations, but you also respond to what your body is doing, and it becomes a positive feedback loop, right? So if your body is showing signs of anxiousness, then it can ramp up. What's nice about music is that because it entrains certain physiological functions, you can strategically use it to alter those physiological responses and in a way help the kind of very physical side of the anxiety. So that's the physical side. So we know that, like, for example, people who listen to music before going into surgery need less anesthetic. because what the anesthetic is doing is ramping down those responses. If they can do that through music, that they're already halfway there. But the other side of it, which is kind of the emotional processing side too, is also really interesting. We have less information about that, but we certainly know that, of course, you listen to music in many different ways, and each way that you listen to music will have a different neural substrate, right? Like if you're just listening it to work out, that's going to be one thing. If you're listening it actively to analyze it, that's going to look very different in terms of your brain activity. We even see that in cases of people who are jazz improvisers, where if they're improvising to a negative emotion, their brain actually looks very different from what it does when they're improvising to a positive emotion. And because we as listeners are often mirroring what we think is happening in the brain of the person who's performing, you can see how that can sort of lead to different types of processing. So I think that we're still understanding all the ways in which music can be used in that kind of a setting, but I think it's potentially very powerful, and I think it's probably very useful for you to sort of to actively think about, like think of your use of music as a kind of treatment protocol, where you kind of, just the way exercise is prescribed, so too might be certain types of strategic uses of music. All right, I've got to get on a plane in an hour and a half, so thank you very much.